Hello. Sometimes data that is provided to us lacks complete metadata and header information as part of the geospatial data itself. A common example of this is author-rectified TIFF imagery that is provided with TIFF world files, but not GeoTIFF tags. GeoTIFF tags can store a complete set of information on details like the projection parameters that the TIFF image is referenced to, whereas a simple world file only provides information on the upper left map coordinate of the image and the dimensions of the pixel, as well as the skew component of the pixels. We usually do know what the projected coordinate system used by the imagery is. It may have been provided in a separate report document, but it is not physically associated with the data in a manner that can be used by a geospatial software package for purposes such as reprojection. So, consequently, this information needs to be reassociated with the data. It's generally not a problem if you have just one or two images of this nature. But if you've been provided with an entire AirPhoto campaign's worth of ortho images, which could be hundreds if not thousands of images, you need a way to batch the process and make sure it happens correctly and doesn't corrupt any of your data. DasImagine actually provides tools to both edit the header of individual images as well as to batch the process across any number of images. This Tech Talk video will step you through the simplified processes provided in DasImagine 2018 and beyond, as well as identifying the pitfalls that may have been encountered in previous versions. So let's go ahead and get started. So first, let's review the TIFF files that we already have. To come up on the Home tab in the Information group and left click on the Metadata button to launch the Image Metadata tool. Once we have the Metadata tool, click File Open and select one of your TIFF files. Now on the Image Metadata Dialog's General tab, note that the Map Information section is incomplete. While the upper left and lower right XY fields are populated with correct map coordinates, and the pixel size XY have valid values of one something in dimensions, there's no definition of the type of unit the pixel size represents. Is it feet, meters, decimal degrees? It's not specified. You can also see in the projection info section is labeled as unknown. These two discrepancies are indicative of a TIFF image which has a world file but no GeoTIFF tags. We can confirm this if we go and click on the TIFF info tab and expand the image. And we can see that there is no GeoTIFF keys subnode in the tree, indicating that this is definitely not a GeoTIFF file, and we just have some basic information coming from the world file. So if we look under the Edit menu of the Image Metadata tool, we can see that there is a Change Map Model option and also an Add and Change Projection option. Now we could use these to correct the projected coordinate system information directly for this one image, but we need to do this for hundreds of files, so we actually need a slightly different approach. To update hundreds of TIFF files in this manner, what we're going to do is come up here to the Home tab again, Information Group, but pull the Metadata menu down and select the Edit Image Metadata option, which will launch the Image Commands dialog. In this dialog, we're going to go ahead and pick one of our TIFF files as an example for the dialog to use. Then we're going to activate the Change Map Model option, turn that on, that checkbox on, and click on the Options button. And in the Map Info Options dialog, we're going to come to Units, pull that menu down and select US Survey Feet. And under Projection, we're going to select State Plane and go ahead and click OK. Back in the image commands dialog, let's left click in the checkbox next to change map projection, and again click on its options, and left click on the edit create projections button to launch the projection chooser. And at this stage we do know the EPSG code for the projected coordinate system we want to use. We could just go ahead and use the various drop down menus to pick the parameters, but we know a predefined setting, EPSG code 2240. Click return and click find, and the software will go ahead and pre-populate those parameters for EPSG code 2240. Again, click OK. Those are transferred to the map projections options dialog. Click OK again, and we're back to the image commands dialog. We've now defined the projection parameters that we want to apply to our TIFF files, and I could click OK, but if I click OK now in this dialog, that will just apply those parameters to the one TIFF file that we selected at the top. What we actually want to do is apply these parameters to multiple files, so instead I'm going to go ahead and click batch. So that has transferred the command we want to apply into the batch command editor. Let me just stretch it out a little bit so we can see the entire command that has been transferred across. Note how the software has automatically created variables for some aspects of the command, but has hardwired other aspects. For example, the input file name is a variable $input, as are the upper left corner coordinates of the data and the cell size. Since these are variabilized, they will be read from each individual input image's header, meaning they will not be changed, or the values that are already present in each input image's header won't get altered from their existing values. Conversely, options such as the pixel units, right here, US survey feet, and the projection, are all set to or hardwired to specific values, meaning that that value will be written to each input image file's header. In versions prior to Erdas Imagine 2018, this would not have been the case. The command would have required manual creation of variables and their insertion into the command. Often this resulted in mistakes in the command and images with the exact same upper left corner coordinates being written to them, and therefore effectively corrupting your original data. Erdas Imagine 2018 streamlines the process and only hardwires the values which we actively changed in the dialogues that we accessed earlier in the image command tool. So we have the command that we want to apply, so let's go ahead and define which files we want to apply it to. Down here we have an input column, so let's go ahead and click add files, and we can go ahead and select all the remaining files, and in this case it's probably just a dozen input TIFF files, but it could be hundreds, it could be thousands of TIFF files which we want to add into the list of files that are going to be substituted for $input and have this command applied to them. We could now, if we wanted, simply click the Run Now button and have the command applied to each input image file one at a time, but our computer might have multiple CPUs and be capable of parallel processing, so left click the Submit button instead. In the Submit dialog, let's change the simultaneous processors to 4. So I'm going to be running 4 of these commands in parallel. Let's left click in the checkbox to close the batch command editor when we submit this. And we're going to go ahead and click OK to start processing now. That's going to bring up a process list, and basically has already gone through all of the 11 TIFF files that we submitted and applied the command to them. So let's go ahead and close the processing list. So at that point we're really done, but if we want we can go ahead and review some of these images. Let's go ahead and have a look at an image. You should note in the status bar at the bottom we now have a projection information being displayed for our TIFF files. Let's go ahead and open up the image metadata dialog, and hopefully what you can see in the map info section, we now have the pixel size is 1 US survey foot for the dimensions, and we have full projection information: state plane, GRS 1980 NAD83, EPSG code 2240. Let's just check to make sure. I'm going to start another one of these image metadata and load one of the other data sets, one of the other TIFF files that we batch processed, just to show that yep, we now have the projection information defined, but things like the coordinates remain different. So we've got a 700 here as opposed to a 200 and so on. So just to prove that we did maintain the correct upper left XY coordinates for each individual TIFF file, but we now have GeoTIFF information. And we can confirm that by going over to the TIFF info tab again expanding the image, and this time as well as the TIFF tags, TIFF keys, we have a GeoTIFF keys tag in the header with the projection information, which does indicate that we have successfully actually inserted GeoTIFF keys into the headers of all these TIFF files. So what were just TIFF files with a world file have now become GeoTIFF files and can be much more easily used in geospatial applications. So you have seen how to successfully use the image commands tool and the batch editor to update the projected coordinate system information associated with multiple TIFF images. Similar steps can be used to efficiently set other parameters on multiple files, such as defining no data, correcting projection information, whatever it may happen to be. This just gives you an overview of using the batch tool and shows you some of the streamlining that has happened with ERDAS Imagine 2018. So that concludes this particular Tech Talk. Thank you very much for watching, and stay safe.